This one's going to be tough, not necessarily for you, but for me. I'm not quite sure how to pronounce Pythagorean Theorem. I thought it was Pythagorean Theorem, but apparently the former is more common. Anyway, if you've ever had a geometry class, you no doubt know about a squared plus b squared equals c squared. That's the formula to calculate the hypotenuse of a right triangle. That's the longest side of a right triangle. The hypotenuse is also the side opposite of the right angle. Now, this isn't math class, but maybe it should have been. This hype template is about quickly calculating the length of the hypotenuse. No doubt this technology would have been banned from my math classes, but what if not? Back in high school, as the math topics advanced, I saw little purpose towards its application. When was I going to use this stuff? Instead of banning calculators, we should have been building them. It's a great way to learn. So let's get to that. Right away, you can notice something's different about the Pythagorean template. It uses HTML range inputs. Two sliders control the length of the sides of the triangle. This is not a default element of hype, but it can be added manually. In this example, simple text boxes are used to hold the custom HTML. Let's take a closer look at one of the sliders. The input tag is used to create the element. The type attribute is set to range. The next three attributes are used to set the limits. The minimum value is 1, the maximum value is 10, and the slider will increase or decrease the value by 0.1 each time it is moved. Those are the settings I picked for this project, but you can use your own values. The same idea applies to identification. The slider has a letter A as the name and an ID of Y. The logic is that this is the A side of the triangle, and it increases or decreases the Y values of the polygon. The range is given a default value of 5. Yet again, this is another design decision. I wanted the sliders to be centered, but since the range is 1 to 10, 5.5 would be the exact center. I wanted whole numbers on startup. Again, you can play with the values and customize how your project works. I picked what seemed ideal for this project, but your project could have different requirements. That's why it's important to understand how the attributes work. The hype element that contains the slider is rotated 90 degrees counterclockwise. Again, this is a design decision. In building the interface, it seemed appropriate to create a closer relation to the side of the triangle being controlled. Little design decisions like this one can separate a good project from a great project. A second slider is placed below the triangle. The attributes for this input tag are similar, but key values are changed. The name and ID have to be different. That's because this input will be controlling a different side of the triangle. By themselves, these inputs do nothing other than change the value. That's where JavaScript enters the picture. When the value is changed, the custom JavaScript reacts to that event and then does something. When the scene is loaded, so is the custom Pythagorean function. The first 4 lines are for orientation. What is the starting location of the box element? Now, you might be wondering, box element? I thought we were creating a triangle. Yeah, that's true, but we're putting that triangle in a box, and that box is invisible. Do you see it now? The box is in the center of the scene. Like a magician doing an act in Las Vegas, there's nothing in the box. No HTML, nothing. So how do we pull a rabbit out of this hat? The magic is going through the code, one line at a time. I even added comments to make that easier. First, we're recording the starting width and starting height of the box. Those values are then used to calculate the center location of the box. You don't actually need to do this part. Yet again, this is another design decision. I wanted the triangle to expand or contract from the center. If you don't care about that feature, the triangle can simply expand or contract from the top left origin. So while the previous 4 lines may or may not be necessary, this next line is critical. It's how the whole thing works. An event listener of input is added. Whenever an input changes, the calculate function is used. In other words, whenever a slider is moved, regardless if it's the A slider or B slider, the project is updated. If you want to learn more about event listeners, the first hero video is related to this topic. Essentially, what was done with the map project is similar to what was done here. Values from the inputs are retrieved. With the sliders, the values are numbers from 1 to 10. This explains the first 2 lines of the calculate function. the x and y values are saved as variables. The y value is from the a side of the triangle, and the x value is from the b side of the triangle. The triangle is a scale model. The units of the sides are not specified. It could be miles or meters. The point is that these values are not pixel values. That's the purpose of the w and h variables. They store the width and height of the triangle. Those values are in pixels. In the next 4 lines of the calculate function, we're setting up the box element. What is the width? What is the height? What is the left location? And what is the top location? These values are set with Hype's JavaScript API. The width and the height values are a direct translation from the w and h variables. Basically, the width and the height changes relative to the starting values. If the number is greater than 5, then increase the size. Otherwise, decrease the size. This goes back to the idea that the triangle should scale up and down from the center. So if you're not sure what's going on with the math, that's why this part is a little complicated. That complexity continues with the left and top values. The starting x and starting y values are center orientated. To set the left and top positions of the box element, half of the width and half of the height is subtracted from the center location. Remember, if you get confused, you can ask questions in the comments. Also, you can challenge yourself by rewriting this code. How could the JavaScript be changed to have a top left origin? Or if you want to use a method that is more common for high school students, how could the JavaScript be changed to have a bottom left origin? The next 2 lines display the slider values on the screen. There are 2 text elements created in Hype. One has an ID value of xv, and another has an ID value of yv. This is such a powerful concept. You can grab a value from an input and then display it on the screen. Don't underestimate how important this can be, because if you can work with data, there's so much you can do. This is quite apparent with the next line of code. It's where we implement the Pythagorean Theorem. First, we can square a value with the math.pow JavaScript function. And let's take a moment to appreciate the name of this function, pow. It reminds me of Mario Bros. Anyway, if you want a value to the power of 2, then the first parameter is the value, and the second parameter is the exponent. This part is calculated first. With another set of parentheses, the values of a squared and b squared are added together. According to the theorem, we now have the value of c squared. So we just use the math square root function to get the value of c. Boom! There's the Pythagorean Theorem in action. And in actuality, this whole project is essentially this one line of code. The rest is just adding a pretty graphical interface. That explains the next part, where the triangle is actually drawn. HTML elements are rectangular. Sure, they can have rounded edges, but if you want something other than 4 sides, that's where a vector shape is used. Well, I suppose that's yet another challenge. This project could be created with just HTML elements. Just add a border to one side, and then rotate that rectangular shape. This is another way to draw the hypotenuse. It's a matter of the requirements and personal preference. I like SVG. So that's the purpose of the following code. SVG is added as HTML. That's the magic that puts the rabbit in the hat. There are 3 main parts to this. The first part is the main SVG tag. This sets the overall size of the image. Do you see how the H and W values were used to set the width and height of the SVG? That's how this code works. This goes back to what was stated earlier. If you can work with the data, there's a lot that you can do. In this particular instance, we're drawing a triangle. That's the purpose of the polygon tag. Similar to what was done with the heart template, we're adding vector points to make a shape. A triangle is a basic 3-sided polygon. It also has 3 points. 0, 0 is the starting point. Then it's just a matter of setting the bottom right and bottom left points. Nice and easy. Well, this could be terribly confusing to beginners, as it's a combination of SVG and JavaScript. If you're having trouble, maybe start with something easier, like a line. That has a starting point and an ending point. A line tag was added to the SVG in order to highlight the hypotenuse. The hypotenuse line is in red, and the numerical hypotenuse value is also in red. Just preview the project to see it in action. By moving the sliders around, the triangle changes size. It's a great way to visualize how the Pythagorean Theorem works. As an example, a 3, 4, 5 triangle is a quick way to show that the Hype project is working. Doubling those numbers works too. 6, 8, and 10. Nice. I think little lessons like this is a great way to engage a math class. Instead of being abstract, the lessons can be interactive. It also gives the information greater meaning, as it has practical application. Do you want to calculate the distance between two elements on a grid? That's the Pythagorean Theorem. This topic is also mentioned in a book about hype, as knowing the distance between two characters can be useful for game development. If you want to learn more about hype, then a book about hype might be helpful to you. And if you want to be notified when new hype tutorials are available, subscribe to Photics TV.